know you've been on the edge of your seat. Here in session 9, I'm going to reveal how the 95% confidence interval tells you something about the p-value. And as a bonus, I'm going to throw in something about what they tell you about so-called negative studies. But to get these valuable insights, you have to look at the confidence interval really carefully. And whenever I want to look at something really carefully, I find a headlamp really useful. You can pick one up like this at your local Ace Hardware store. Good. Let's look at some fine detail. Here we go. 95% confidence intervals provide the range of plausible effect sizes given what is observed in the study. And it's the effect size in concert with the outcome measure that determines the clinical importance, not the p-values. So don't go surfing p-values, remember? CIs also speak to how sure we are about the effect size. Look at that confidence interval. It's pretty tight. We're sure where the effect size is. Now, if the confidence interval is a little longer, we're a little less sure. Longer still, we're even less sure. And the longer it gets, the less sure we are where the effect size is, until we're totally unsure. Now we have a little bit more formal language for this. When we're really sure, we say the estimate is precise. When we're unsure, we say it's imprecise. So let's talk about 95% confidence intervals and their relationship to p-values. If the p-value is greater than 5%, that is, there's no significant difference, then the 95% confidence interval should include no difference between the two groups. So here's the confidence interval. Somewhere in that confidence interval should be no difference between two groups. And the effect size may be on the other side, but as long as the confidence interval includes no difference between the two groups, the p-value is greater than 5%, no significant difference. If the p-value is less than 5%, then the 95% CI should not include no difference between the two groups. So a statistically significant finding, the confidence interval doesn't include no difference between the two groups. And again, the effect size can be on the other side, but both these last two studies are statistically significant studies. Now, the reason I told you have to be very careful when you're looking at this is because the value of no difference differs. That's a tongue twister. Let me try that again. The value of no difference differs. Wow. When the effect size is measured as a subtraction, an absolute change, no difference is 0. So it can range from negative, 0 to positive, like this. 15 versus 8%, 95% CI for the 7% difference, 2 to 12%. Well, that doesn't cross 0. That's somewhere over here. That's going to be statistically significant, p less than 0.05. How about this? The PSA rose 2 points, 95% CI minus 1 to 5 points. Well, that includes 0. That's crossing no difference. That's not a statistically significant difference. Now, when the effect size is measured as a ratio, that is a relative change, no difference is 1, right? When the numerator and the denominator are the same. So now we can range from less than 1 to greater than 1. No difference is 1. Try this. Relative risk 1.4, 95% CI 0.8 to 2.4. Well, that crosses 1, doesn't it? That's not a statistically significant finding. How about this? Relative risk of 0.6, 95% CI 0.4 to 0.8. That's all over here. It's all less than 1. It doesn't cross 1. That's a statistically significant finding. So that brings me to the key points. The 95% confidence interval contains information about statistical significance. If the CI includes no difference, then P is greater than 0.05. If the CI does not include no difference, then P is less than 0.05. And the trick is to know what no difference is. Is it 0 or is it 1? Now, confidence intervals also give you a feel for the magnitude of the p-value. Imagine a nice tight confidence interval well away from no difference. That's going to be highly statistically significant. A p, say, less than 0.001. But as the confidence interval begins to approach no difference, the p-value will get higher. It gets really close, maybe p equals 0.04. And in fact, if the confidence interval terminates on no difference, p equals 0.05. That's a fun fact to tell your friends. As it continues to stay close to no difference, the p-value will go up, but it's still around 0.05. It's 0.06. And as it gets farther away, the p-value gets larger and larger. Here, I'm imagining it's 0.25. So that's the second point. 95% CIs also communicate the magnitude of the p-value. If the 95% confidence interval ends near no difference, then the p-value will be very close to 0.05. If it ends far from no difference, then the p-value will be more extreme, and you have to look at it to see which direction it will be more extreme. This takes a little practice to get used to, but you'll begin to notice the relationship between the confidence interval and the magnitude of the p-value. Now finally, let's touch on why confidence intervals are particularly useful when considering negative studies. And by negative studies, I mean one in which no significant difference is found, where the p is greater than 0.05, a null finding. Like this one. There was no significant difference between new drug and placebo in preventing heart failure. So we know the confidence interval crosses no difference, and this is a pretty tight one. It's a precise estimate. But as the confidence interval gets longer, we're less sure exactly where the effect is. And maybe at some point we just say, wow, that's really imprecise. Look over here. New drug might prevent heart failure. It may be a really important drug. That's still possible. But it's also possible that new drug might cause heart failure. It's so imprecise, we don't know. Now that leads to the question, are all negative studies equal? Once you say the study's negative, is there nothing else to learn? Well, there's more information than that. Consider these 4 studies. Now notice they're all negative studies. The confidence intervals all include a relative risk of 1. Their p-values are all greater than 0.05. But they don't have the same information. These first 2, we're very certain that the effect is small in either direction. It's tiny. But this third one, there might be something worth exploring here. Looks like most of the confidence interval is benefit, and the main estimate of the effect size is very beneficial. While this fourth one, wow, that situation is grim. No reason to study that any further. That looks like that dog won't hunt. So that's the third point. A 95% CI is particularly useful in assessing a negative study. And a negative study with a wide confidence interval may be obscuring a clinically important effect. So are you really still driving that gas-guzzling internal combustion engine? Yeah, that's terrible. You ought to really move up to a hybrid. Hey, back off. Confidence intervals provide a lot of information. The p-value really only gives you one piece of information, the probability that the observed result is due to chance, while a 95% confidence interval provides you with 2 pieces of information, the probability that the observed result is due to chance and the range of plausible effect sizes given what's observed. That's a lot of information, and if you want to get it, you need to look at that confidence interval carefully. Go ahead and take the assessment now.